All right, still Sunday night, still St. Mark's. Um, Now it's though 8:24, and I'm going to demonstrate for you how I'm going to form these logger pro graphs that we're going to use together in the collision lab. We have two motion detectors, one here and one here. I set them on cart because I'm using carts. Cart, okay. Now, I'm going to have to mask these carts. I think they're around 250 grams, but I wouldn't swear to it, so I'm going to mask them to make sure. I've got a red cart and a blue cart. And when I do the graphs with the motion detectors, I'm going to do a couple of things. I'm going to make sure that there's usually a red graph and a blue graph. I'm going to make sure that the red graph goes with the red cart and that the blue graph goes with the blue cart. Also, I have to pick a direction for positive. So I think I'll pick that way. Well, then let's see, for your point of view, okay, let's say that way is positive. That way is going to be positive. That means that this motion detector is going to read positive velocity when it goes in that direction. And that's good. I don't have to do anything with this motion detector, which, by the way, is hooked up to DigSonic 2. That little port right there on the LabQuest Mini. This one's hooked up to DigSonic 1, but I want positive to be that way, but normally this thing's going to read negative. So I have to do something on Logger Pro that's called reverse direction. I'll show you how to do that when we're doing the lab. Now, what I'm going to do is I'm going to have various types of collisions between the two carts. And then we're going to investigate the momentum of each cart and the system of carts before and after the collision, and also the kinetic energy. And so we're going to see whether the momentum of the two carts, the system of two carts, is the same before and after the collision, and also is the kinetic energy the same before and after the collision. So that's what we're doing here. So the first collision is a perfectly inelastic collision. Okay, a perfectly inelastic collision is one where the objects stick together. And that is achieved by using Velcro. So I'm going to have this guy go in that direction and hopefully collide with the other cart. And so I press collect on the motion detector. This thing's not quite level, unfortunately. And then, so I press collect on Logger Pro, and the motion detectors start clicking, and then I just do this. Okay, so that's collision number one. They stuck together. This one was sitting still. This one was moving in the positive direction, and that's collision number one. Collision number two, a perfectly inelastic collision of two carts with unequal masses where one cart is moving initially and one is initially at rest. Okay, so, it doesn't matter. Here's the bar, 250 gram bar that I'm going to put in one of the carts. Let's put it in this one, I guess. And I want another perfectly inelastic collision. One of them's at rest. Okay, you do the same kind of thing. And here we go. I press collect and boom, that's it. Okay, and that makes a graph and we analyze that graph. And then number three, a perfectly inelastic collision of two carts with equal masses moving in the same direction, and one of the carts is rear-ended. Okay. So again, this is another perfectly inelastic collision, so they're going to stick together. And so I hit collect, and I do that. And so the red cart catches up with the blue cart and sticks to it. And that's that collision. And then collision D, the fourth collision, A perfectly inelastic collision of two carts with unequal masses initially moving in opposite directions. Okay, so let's put the mass into the red cart, click collect, and boom, like that. So that's number 4, or D in the lab. Then E, we're going to have an elastic collision. So the elastic collision is one where they don't stick together and a special thing also happens. So, for instance, the collision between molecules in an ideal gas, those are called elastic collisions. So in order to do that, we take advantage of the other thing that these carts have, which is magnets. And so we're going to kind of like fake a perfectly elastic collision. So this one is two carts where one is moving and the other isn't equal masses. So that's going to look like this. Click collect, and here we go. Boom, like that. One cart comes to a stop, the other one moves on. So that's a collision which is elastic. And then finally, a collision, elastic collision again, of two carts of unequal mass, initially moving the same direction and one of the carts is rear-ended. Oh, that could be fun. All right, so let's put this on the red cart again. And here we go, click collect, boom, like that. And so that is the 6th collision F. Yeah, so that's the physical part of the lab. The major part of the lab is analyzing the graphs. And so that's what we're still going to get to do. It would be nice if we could do all of this in person, but you know, even if I was here, there's a bunch of students that are remote. So it's really going to be hard to do this in any other way that's fair to everybody, unless we do it like this. So that's that. I'll form these graphs later, and I'll keep them separate, know which one it is, and I'll show them to you. So I'm going to form them now, and then we'll discuss them and do a lab with them soon.